Hi guys, sorry I'm not there to present these notes in person, but what we're going to start talking about today is atomic orbitals, which leads into electron configuration. You're going to copy this set of notes on ISN page 57. It does not have to be in Cornell format unless you'd like for it to be. And this actually goes with Chapter 5, Section 1. So remember, with video notes, you can pause, rewind, and replay as often as necessary so that you get all of the information. There is a skeleton version of this whole set of notes available on Edline, but I changed it a little bit since I'm going to be presenting it from not in class. Okay? So again, don't forget you can pause, rewind, fast forward as often as necessary. Oh, replay, not fast forward. Don't fast forward. Okay, first thing we're going to talk about, we recently talked about Bohr, Niels Bohr, but after Niels Bohr we actually came up with the quantum mechanical model. The quantum mechanical model is the modern description of electron movement in atoms based on mathematical calculations. Schrödinger actually is the one who came up with this mathematical model. And so this quantum mechanical model determines the allowed energies an electron can have and how likely it is to find the electron in various locations around the nucleus. So essentially we're looking to see the quantum mechanical model can predict where an electron could be at a point in time. It doesn't ever tell us exactly where the electron is, but it's just a mathematical formula to figure out where it most likely is at a given time. Now looking at atomic orbitals, hopefully this part's familiar. You know that an atomic orbital is a region of space in which there's a high probability of finding an electron. We also have principal energy levels. We've also called them electron shells or energy levels that we label by numbers. And then for each energy level, there may be several orbitals with different shapes. That's where it gets different. Previously, we've talked about our electrons looking kind of like, let's see if I can draw one for you, where we've got our nucleus in the middle, and then we've got our electron shells around the outside, and then we can label those as like 1, 2, and 3. That's ugly, 3. That is how we've talked about it so far. But we're about to find out in the quantum mechanical model, there's actually different shapes for our orbitals. And so that's what we're going to look at next. So the easiest way to kind of see this is to include this table in your notes. So we've got our energy levels, and then we say that those energy levels have sublevels, which kind of describes the actual orbital, which is the space where we can find that electron. So each energy sublevel corresponds to an orbital of a different shape, which describes where the electron is likely to be found. We use letters to describe these shapes, and I'll try and give you some nicknames for those sublevels, shapes, to help you kind of remember what's what. But if we're looking at our first energy level, there's only one sublevel, and the type of sublevel we have is an S sublevel. So that's the name for it, is the S. And since we're on the first energy level, we label it 1S. When we go up to the second energy level, there's two different kinds of sublevels. There's S and there's a P sublevel. Now that P sublevel is actually made of 3 orbitals, versus your S is just 1 orbital. So the S is usually described as a sphere, S for sphere. Then you have P, and I usually say P is for petals, and I'll draw you a picture of these. Well, I'll show you a picture and then I'll draw some. And there's actually 3 orbitals within those petals. Our third energy level is where things start to get really complicated. This is anything after element 20. It gets weird because you hit your transition metals. So then you can have an S orbital, you can have your 3 p orbitals per sublevel, or per energy level, and then you get to the D. I don't really have a good way to describe D other than it's kind of dumb, but I can't actually say that because it's sort of important. The D is maybe like dumbbells, and so when I sketch those for you, you'll be able to understand how they look. And then we get to our 4th energy level, and the same goes for 5th and 6th. You can have all the way to an F. The F is the one that can hold 32 electrons. It's like a crazy flower. So anyway, that's kind of the easiest way to look at those, and I'll show you pictures of those right now. All right, so here we are taking a look at the electrons in their orbitals. And so first of all, I'd like to kind of point out over here this energy level N. That's just describing which energy level we're talking about. So at energy level 1, there's only one sublevel, and that's an s orbital. It can hold a maximum of 2 electrons. And so I want to draw your attention to this picture over here, which actually shows you what the shape of the different orbitals are. So our s orbital, there's only one s orbital per energy level, and it is shaped like a sphere. I would encourage you to draw them. If you don't draw them here, you're going to have to draw them in like 2 slides, so you may as well draw them now. Then if you look down here at the right side where it's a p orbital, this is only one p orbital, but there are 3 possible p orbitals. And see how they kind of look like petals? There's another p orbital on the y-axis, and there's a p orbital on the x-axis. So they're actually showing you 3 dimensions here. There's an x, a y, and a z-axis. So obviously it's a 3-dimensional thing, but they kind of look like petals to me. So if I were to loop them around, those would be my 3 p orbitals going this way, and that way. So then those show up in your second energy level. So you have sublevel S for your sphere and your P for your petal, and you can have a total of 8 electrons. So if you think about an element like neon, which has 2 electrons in the first energy level, which we know about, and we know that there are 8 in the second energy level. This is just showing you how they're organized. So in the first energy level, they're both in this cute little sphere. And then outside that, when you bump up to the next energy level, they're in a bigger sphere, and then 6 additional petally shapes outside of that bigger sphere. When you get into the third energy level, as I told you before, you get an S, a P, and then a D, which is more shaped like a dumbbell. And then that can hold up to 18 electrons. I told you it gets crazy. And then your fourth energy level and on, you have S, P, D, and F. And again, the F energy level is like a really crazy flower. And those can hold up to 32 electrons. So predominantly, we're going to be dealing with the S and the P orbitals, especially if I were ever going to have you draw them. So I did want to take a quick minute to practice drawing the shapes. So your S orbital is literally a sphere, and then you imagine if this were like your graph. Now then you come over here, and if we were trying to draw our P orbital, change my color for that. We'll do purple. Alright, so you've got your P orbitals like here, and then there's one here and there. And then there's this, like, I don't know, I wish I could draw a dotted line better, because that one's like coming at me. So essentially somewhere around in here there would be an electron and an electron zipping around. And then here, one electron can live here, one electron can live there, one can live here, one can live here, one can live here, and one can live here. So I can have 6 electrons in this area and 2 electrons in this area. And so that equals the 8 electrons that we see on like your second energy level. And almost finished. I wanted to show you how this is organized on the periodic table. I think this is actually really, really cool. If you can understand this, it makes the next task, which is actually electron configuration, a whole bunch easier. Now keep in mind, helium is funny. Helium really belongs over here. I'm going to draw a big arrow. Okay, and let me write my HE right here. Because helium, essentially, for electron configuration, should live over there. So what you see is you have the ones that are in the s orbitals are over here, and we actually call this the S block on the periodic table. It almost makes it sound like it's jail, but this is your S block. And so every single element in this category it'll actually tell you on this particular periodic table what their s orbital level is. So like hydrogen only has 1 electron, so it's a 1s, versus lithium has 3 electrons. They're going to fill up the first s level, but then they're going to start the second s level. So this is your s block. Then I'm going to come over here to the green area. The green area is called the p block. That means that when you're in that area, you're going to start to fill up the p orbitals. Remember, those are your petal-shaped ones. So we're going to fill up our spheres and then move on to the petal shapes. Well, I talked about neon a second ago, so we'll talk about neon again. Neon's got a full first energy level because it's got 2 electrons in that first inner sphere. Then it's got 2 electrons in the second sphere, so it filled up 1, 2, and then it filled up the next 2, and then it's actually going to fill up 1, 2, 3, 4, 5, 6 petals, and that actually completes. It's got a full second energy level. When you get into this middle yellow section, those are our transition metals. They're really funny and they do crazy things, and those are the ones that are in the D block. And then way down here in the light blue weird color, that's the F block. That's actually your lanthanide and your actinide series. Those are really like super transition metals. Those are extra crazy, and I will not ask you questions about those, to be honest, just because they're kind of scary. A lot of those are our newly discovered elements as well. Anyhow, that is the notes portion. Let me go ahead and show you what your classwork homework is, and then as soon as you're finished copying notes, remember you can go back and rewind and rewatch if you need to. So the homework, which I would start on right now, you're going to copy and answer questions, or answer the questions in complete sentences. They're going on ISN 56. Hopefully you got your notes on 57. If you're using a textbook, it's on page 132. If you've got an iBook, it's on page 271. You're answering questions 1, 2, 3, 4, skip 5, but you're doing number 6. And number 6 is part A through E. So it's 5 problems, just not number 5. Anyway, and this is what you're working on in class right now, and I hope to be back tomorrow. Sorry, Lila's been sick. All right, thank you very much. Have an excellent afternoon.